The two greatest threats facing humanity, according to the United Nations, are climate change and emerging infectious disease, particularly pandemic influenza. But what of primary prevention, the possibility of preventing the emergence of pandemic viruses in the first place? Like cancer, the root cause is likely multifactorial, difficult to tease out, but a question worth exploring nonetheless, and the question I'd like to address here today. Now, bird flu, but from where do emerging diseases emerge? Well, let's go back a bit further, much further. Human beings have been on this earth for millions of years, yet throughout most of human evolution, there were no epidemic diseases. No one ever got the measles because measles didn't exist. No one got smallpox, no one got the flu, not even the common cold, until about here, 10,000 years ago. Medical anthropologists have identified three major periods of disease since the beginning of human evolution, and the first started just 10,000 years ago with the domestication of animals. When we brought animals into the barnyard, they brought their diseases with them. When we domesticated cows and sheep, for example, we also domesticated their rinderpest virus, which turned into human measles, now thought of as a relatively benign disease. Over the last 150 years, measles has killed 200 million people. And in a sense, all those deaths can ultimately be traced back just a few hundred generations to the taming of the first cattle. Smallpox likely came from camel pox. We domesticated pigs and got whooping cough. We domesticated chickens, and we got typhoid fever and typhoid Mary, and domesticated ducks and got influenza. Before the domestication of ducks, likely no one ever got the flu. Leprosy likely came from water buffalo, and the common cold from horses. How often did wild horses have the opportunity to sneeze into humanity's collective face until they were broken and bridled? Right? Until then, the common cold was presumably only common to them. In his Pulitzer Prize-winning book, Guns, Germs, and Steel, Professor Diamond tried to explain why the diseases of the landing Europeans wiped out up to 95% of the Native Americans and not the other way around. Why didn't Native American plagues kill the Europeans? Well, because there were no plagues. In his chapter, Lethal Gift of Livestock, he explains how before the Europeans arrived, we had buffalo, but no domesticated buffalo, so no measles. American camels were wiped out in the Pleistocene Ice Age, so no smallpox. No pigs, so no pertussis, no chickens, so no typhoid. So while people were dying by the millions of killer scourges in Europe and Asia, none were dying with diseases in the so-called New World because there weren't essentially farm animals to domesticate. There wasn't this spillover of animal disease. The next great period of human disease started just a few hundred years ago with the Industrial Revolution of the 18th and 19th centuries, leading to an epidemic of the so-called diseases of civilization: diabetes, obesity, heart disease, cancer, etc. But by the mid-20th century, the age of infectious disease, at least, was thought to be over. We had penicillin. We conquered polio, eradicated smallpox. In fact, in 1968, the U.S. Surgeon General declared the war against infectious disease has been won. In 1975, the dean of Yale School of Medicine pronounced that there were no new diseases to be discovered, except maybe lung cancer. But even Nobel laureates were seduced into the heady optimism of the time. One famous virologist wrote in a 1962 textbook, to write about infectious disease is almost to write about something that's passed into history. The most likely forecast about the future of infectious disease, he wrote, is that it will be very dull. But then something changed. After decades of declining infectious disease mortality in the United States, the trend has reversed in recent decades. This is a graph from the CDC of infectious disease mortality over time, over the last 50 years or so. And as you can see, it starts declining, 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 declining. But then around 1975, it started to go back up. The number of Americans dying from infectious disease started to go back up. Starting around 1975, new diseases started to emerge and reemerge at a rate unheard of in the annals of medicine. More than 30 new diseases in 30 years, mostly newly discovered viruses. In fact, the whole concept of emerging infectious disease has gone from a mere curiosity in the field of medicine. Now it's an entire discipline, really moved to center stage. We may soon be facing, according to the U.S. Institute of Medicine, what they call a catastrophic storm of microbial threats. We are now smack dab in the third era of human disease, which seems to only started about 30 years ago. Medical historians have called this time in which we live the age of emerging plagues, almost all of which come from animals. But we domesticated animals 10,000 years ago. What has changed in recent decades to bring us to this current situation? Well, we are changing the way animals live. Take Connecticut, for example, where in 1975 Lyme disease was first recognized, since spread across all 50 states, affecting an estimated 100,000 Americans since its emergence. Lyme disease is caused by bacteria-infested deer ticks, but the primary host is actually not deer, but the white-footed mouse. The ticks themselves, not quite as cute, really, but we've been sharing the woods with these fellas forever. What changed recently was suburbia. The black-legged ticks live on the white-footed mouse, kept at bay by woodland predators, but then developers came in and chopped up America's woodlands into subdivisions, scaring away the foxes and bobcats, and now we have more mice, more ticks, and more disease. We are changing the way animals live. Going back a little farther, with the big cattle-producing nations fighting during the Second World War, what Argentina did took advantage of the situation by dramatically expanding its beef industry at the expense of its rainforest. There we discovered the deadly Hunan virus, or rather it discovered us, and the so-called hamburgerization of the rainforest exposed hemorrhagic fever viruses all across the continent subsequently. Experts believe the most likely scenario is that HIV arose from humans sawing their way into the jungle, butchering chimpanzees for their flesh along the way. Now, in many countries in Africa, the prevalence of HIV exceeds 25% of the adult population, leaving millions of orphan children in its wake. Someone butchered a chimp a few decades ago, and now 25 million people are dead. But wildlife has been hunted for thousands of years, yes, but never before like this. With the demand for wildlife meat outstripping local supplies, what countries have done is set up these intensive captive production farms, cramming wild animals in these cramped, filthy cages and then smuggling them around the world. This intensive commercial bushmeat trade actually started in the live markets of Asia, particularly the Guangdong province, a southern province surrounding Hong Kong, from which the current bird flu threat arose. The live animal markets took a class of viruses which in human medicine we had only known for causing the common cold and seemed to turn them into a killer SARS. New diseases spread. But there's one way we have changed our relationship with animals that really outshadows all the rest. In response to this torrent of emerging and re-emerging infectious diseases, the world's three leading authorities got together for a joint consultation. The World Health Organization, the Food and Agriculture Organization in the United Nations, and the World Organization for Animal Health, the world's leading veterinary authority, got together to uncover the key underlying causes of this age of emerging plagues. They came up with four main themes of risk factors for the emergence and spread of these new diseases. Yes, they talked about the exotic pet trade, they talked about bushmeat, but number one on their list was this increasing demand for animal protein the world over. Yes, we domesticated animals 10,000 years ago, but never before like this, especially pigs and poultry. Chickens used to peck around the barnyard, But now chickens raised for meat are typically warehoused in sheds containing tens of thousands of birds. About half of the egg-laying hens on this planet are now confined in what are called battery cages. These small barren wire enclosures extending down long rows in windowless sheds can be up to 1 million birds on a single farm. About half of the pigs on the planet are now, again, crowded into these intensive confinement operations. You know, old McDonald's farm has since been replaced by the new McDonald's farm. These intensive systems represent the most profound alteration of the human-animal relationship in 10,000 years. And no surprise, they are breeding grounds for disease. Then the diseases of industrialization, and finally, of land use and agricultural intensification. We took natural herbivores like cows and sheep, turned them into carnivores and cannibals by feeding them slaughterhouse waste, blood, and manure, and then we took downed animals, too sick to even walk, fed them to people, and now we have mad cow disease. We feed antibiotics to farm animals by the truckload. This is the total amount of antimicrobials used for all of human medicine every year. Now contrast that with the amount we feed to farm animals just to promote growth or prevent disease in such a stressful, unhygienic environment. Millions of pounds a year. And now we have these multi-drug resistant bacteria, and we as physicians are running out of good antibiotic options. The others. With the seeming propensity of industrial animal agriculture to churn out these novel, lethal human pathogens, what if these animal factories gave rise to a virus capable of a global pandemic of disease? But there's only one virus on the planet that can rapidly infect billions, and that's influenza. Dr. Robert Webster, the world's leading authority on bird flu.
If we go back to 1918, 2.5% of people died. How many people are dying with bird flu? 50%. We've never seen such an event since the time of the plagues.
Up to 60 million Americans come down with the flu every year. What if it suddenly turned deadly? That's what keeps everyone up at night. The possibility, however slight, that a virus like H5N1 could trigger a human pandemic. That'd be like combining one of the most contagious known diseases, influenza, with one of the deadliest, like crossing a disease like Ebola with the common cold. The reality, though, is that the next pandemic may be more of an unnatural disaster of our own making. So to slow down or stop this rapid recent emergence of highly pathogenic flu viruses, one must first ask, well, what triggered this avalanche in the first place? Well, the senior correspondent, NewsHour with Jim Lehrer, posed that question to Dr. Webster, the so-called godfather of flu research. Was there something qualitatively different about this last decade made it possible for this disease to do something it's never done before, some kind of change in conditions that suddenly lit a match to the tinder? Webster replied. He said, farming practices have changed. He talks about growing up on a farm. But now, we put millions of chickens into a chicken factory, next door to a pig factory. And this virus has the opportunity to get in one of these chicken factories and make billions and billions of these mutations continuously. And so what we've changed is the way we raise animals and our interaction with those animals. Factory farms, it seems, can be thought of as the incubators for the emergence of highly disease-causing strains of this virus. And all bird flu viruses start out harmless. To both birds and people, very important to understand, they start out harmless. Avian influenza has existed for millions of years as an harmless intestinal virus of aquatic birds like ducks, waterborne virus. They say, well, how does a duck's intestinal bug end up in a human cough? Well, in people, the virus must make us sick in order to spread, must make us cough in order to shoot virus from one person to the next. But in the virus's natural reservoir, aquatic birds like ducks, the virus doesn't need to make the duck sick in order to spread. In fact, it's in the virus's evolutionary best interest not to make the duck sick, as dead ducks don't fly very far. So the virus silently multiplies in the intestinal lining of the duck, is secreted out into the pond water, is swallowed up by another duck, and the cycle continues as it has for millions of years, and no one gets hurt. But if an infected duck is dragged to a live bird market, for example, crammed in cages high enough to splatter virus-infected feces on land-based birds, terrestrial birds like chickens, well, then the virus has a problem. If the virus finds itself in the gut of a chicken, it no longer has the luxury of easy waterborne spread. Chickens aren't paddling around in the pond. So the virus must mutate or die. Unfortunately for us, mutating is what influenza viruses seem to do best. So in its natural reservoir, it's been described as being in total evolutionary stasis, harmless. But when thrown to a new host, like land-based birds, it quickly starts mutating, acquiring mutations to adapt to its new host. In the open air, it must resist dehydration, for example, and it may have to spread to different organs to find a new way to travel. The intestines ain't going to work anymore, and it may find the lungs and become an airborne pathogen, which is bad news for terrestrial mammals such as ourselves. Goes into chickens as an aquatic virus, but may come out as the flu. In its new host, the more virulent, the more violent this virus becomes, the quicker it may be able to overwhelm the immune system of its new host. But if the virus becomes too deadly, though, it may not spread as far. In an outdoor setting, at least, if the virus kills its host too quickly, the animal may be dead before it has a chance to spread to too many others. So in nature, there's kind of a natural limit on how virulent these viruses can get, or at least there was until now. Enter intensive poultry production. When the next beak is just inches away, there may be no limit how nasty these viruses can get. Evolutionary biologists believe that this is the key to the emergence of hypervirulent, predator-type viruses like H5N1. Disease transmission from... So you put all these factors together, and what you have is this kind of perfect storm environment for the emergence and spread of new superstrains of influenza. In 2007, the Journal of the American Public Health Association published an editorial that went beyond just calling for de-intensification of the poultry industry. They questioned the prudence of raising so many chickens in the first place. In their editorial, Chickens Come Home to Roost, it is curious that changing the way humans treat animals, most basically ceasing to eat them, or at the very least radically limiting the quantity of them that is eaten, is largely off the radar as a significant preventive measure. Such a change, if sufficiently adopted or enforced, however, even at this late stage, could still reduce the likelihood of the much-feared influenza pandemic. It would even more likely prevent unknown future diseases that, in the absence of the change, may result from farming animals intensively and killing them for food. Yet, humanity does not even seem to consider this option. We don't tend to shore up the levees until after the disaster. Hopefully, it won't take a pandemic before we take these recommendations into account. The U.S. Department of Homeland Security is now using as a key planning assumption that the U.S. population may be directed to remain in their homes under self-quarantine for up to 90 days per wave of the pandemic to support social distancing. Everyone ready to stay in their homes for 3 months? Right? If we have to go out to the corner store during a pandemic to buy toilet paper or something, we may be bringing back to our family more than just groceries. Along with human culpability, though, comes hope. If changes in human behavior can cause new plagues, well then changes in human behavior may prevent them in the future. Thank you.